Welcome to Daily Papers, the podcast where we break down fascinating research papers for everyone. Today, we have a fantastic story that feels like it's come full circle. It's about a mathematical puzzle from 1937, long before computers as we know them even existed.
And the twist is that this nearly 90-year-old puzzle was just solved by the very technology it helped create, modern AI models like ChatGPT and Gemini. It's like a grandfather getting career advice from his great-grandchild.
Exactly. The paper is called How AI Settled the Complexity of the Oldest SGD Algorithm. So let's start with that algorithm. In 1937, a Polish mathematician named Stefan Kaczmarz came up with a simple way to solve a system of linear equations.
Okay, system of linear equations might already sound a bit scary. Let's break that down. Think of it like a giant Sudoku puzzle. You have a bunch of rules or equations that all have to be true at the same time. The goal is to find the one set of numbers that satisfies all the rules.
That's a great analogy. Now, Kaczmarz's method was clever because it didn't try to solve the whole puzzle at once. Instead, it would look at just one rule, one equation, and find the closest possible answer for that single rule. Then, it would update its guess.
And then it would just pick another rule at random and do it again, make another tiny adjustment?
Precisely. Step by step, one piece at a time, it slowly gets closer and closer to the true solution that works for everything. Now, here's the amazing part. This idea from 1937, making small, incremental progress by looking at just one piece of the data at a time, is the fundamental concept behind how we train almost all modern AI models.
You mean like ChatGPT?
Yes, it's called stochastic gradient descent, or SGD. When you train a large language model on the entire internet, you can't possibly load all that data into a computer at once, so you use SGD. You show the model one small piece of data, say a sentence, it makes a small adjustment to get better, and you repeat that billions of times. Kaczmarz's algorithm is the oldest known example of this exact idea.
Wow, so the DNA of modern AI is almost a century old. So if we've been using this idea for so long, what was the mystery that needed solving?
This is where we get to what the paper calls the theory-practice gap. For decades, mathematicians could only prove that the Kaczmarz algorithm worked well under one weird condition. You had to average together every single guess the algorithm made along the way.
Wait, that sounds incredibly impractical. In our Sudoku analogy, it would be like writing down every single number you pencil in, and then at the end, averaging all your attempts to get the final answer. Nobody would do that. You just care about the final filled-out grid.
Exactly. In AI training, nobody averages all the past versions of the model. They just use the most recent one, the one after all the training is done. It's called the last iterate. And for decades, nobody could prove that the last iterate of the original Kaczmarz algorithm was actually, well, good. Does it converge to the answer quickly and reliably? That was the open question.
So theory said average everything, but practice said just use the last one. And this paper finally proves that practice was right all along.
It does, but how it was proven is the real story. The two human authors, Michał Dereziński and Xiaoyu, decided to use AI to solve the problem about AI.
So meta. How did that go? Did they just type the problem into ChatGPT and it spit out the answer?
Not even close. First, they tried a fully autonomous approach. They gave the problem to ChatGPT, and ChatGPT's response was basically, "I'm sorry, I can't solve this. This appears to be a current open problem in mathematics." It even cited one of the author's previous partial results on the topic.
That's hilarious. What about the other AI they used, Gemini?
Gemini was much more confident. After several hours, it came back and said the solution is affirmative, and proceeded to lay out an argument. The problem was, the argument was a total mess. It made unsupported claims, it was incomplete, and it even cited a theorem from a paper that didn't actually exist in that paper. The authors called it a blunder.
Okay, so it seems like the AI failed.
That's what you'd think, but here is the absolute key to the whole story. Buried inside Gemini's flawed, overconfident proof was one truly brilliant and creative spark. It made a connection to a completely different and highly advanced branch of mathematics that the human researchers hadn't considered at all.
So even though the proof was wrong, the core idea was a diamond in the rough.
Exactly. The human authors recognized this spark of insight. They said, wait a minute, this specific argument is nonsense, but the overall direction is a promising new way to attack the problem.
So what did they do?
They took Gemini's creative blunder, stripped away all the incorrect parts, and wrote it up as a short, clean summary of a potential strategy. Then they gave that document to ChatGPT.
So they used one AI's creative blunder to give a hint to another AI.
Yes, and this time, with that crucial hint, ChatGPT was able to produce a complete and correct proof. It finished the job. It was a true collaboration. One AI provided a novel, creative insight, the humans filtered and guided that insight, and another AI executed the technical steps to create the final proof.
That is incredible. So the 90-year-old problem is finally solved. We now know for sure that this foundational algorithm works just the way people have been using it in practice for years. The last guess is officially good enough.
That's right. The theory now matches the practice. And this proof doesn't just apply to the Kaczmar's algorithm. It helps us better understand the fundamentals of SGD, the engine that powers so much of the modern AI world.
But the bigger story seems to be about the nature of discovery itself. It's not about AI replacing human scientists, but this messy, beautiful, and powerful collaboration where humans and AI can work together, leveraging each other's strengths.
It's a fascinating look at what the future of scientific research might be, and it's a perfect case study of AI helping us understand its own origins. Thanks for tuning in to Daily Papers.